Ladies and gentlemen, I'm very pleased to introduce you to Dr. Jessica Small, who is the Associate Director at the Virginia Institute of Marine Sciences, ABC. Jessica, before you talk about yourself and your background, tell us quickly what ABC stands for.
So ABC stands for the Aquaculture Genetics and Breeding Technology Center at VIMS. We're primarily focused with oyster breeding.
Okay, all right, we're going to go there, but first, let's hear about you, please. Where did you grow up and go to school, and how did you and VIMS come together?
Great. So actually, I was born in New Hampshire, but I spent most of my life in Massachusetts. I did my undergrad up there at the University of New Hampshire, so have a bachelor's degree in marine and freshwater biology. After my undergrad, I took some time exploring here and there, went to school in Australia for a little while, and then decided to go to grad school. And I came to the Virginia Institute of Marine Science in 2003 to pursue my PhD, and received my PhD in 2007.
And what did you get your PhD in?
So marine molecular genetics. So I've spent a lot of time in the past focusing on genetics and diagnostics primarily.
My gosh, okay. All right, so you get that, and then what happens?
So after finishing my PhD, I spent some time abroad in the UK, came back to VIMS in 2008, 2009, did some work on a virus that infects spiny lobsters in the Caribbean, worked on shell disease in American lobsters, and then in 2012, there was a position opening in this department in ABC, and so I joined this department in 2012, and I've been here for about the past 5 years.
That is wonderful. All right, please, we're gonna learn how you reproduce baby oysters.
Okay, great. So the process that we do here at the hatchery is called strip spawning. It's a little bit different than what would occur in nature, so I'll just walk you through that. Through a process called conditioning, we actually trick oysters into thinking it's time to spawn. So they put on eggs and put on sperm, and they become very ripe. How we know that they're ripe is we look at them under a microscope, and we can actually see a part of their body which becomes gonad, or material that has either eggs or sperm in it. Once we see that they have those eggs or those sperm, we do a process called strip spawning. So if it was a female oyster, we might take a cup like this and a scalpel, and we very gently scrape the eggs into a beaker here, rinsing continually with seawater, because seawater is where the oysters came from. Similarly, we do the same process with males. So we have eggs in one cup and we have sperm in another cup. We do some assessments to look at the quality of the eggs and the concentration of them. We also look at the quantity and the motility of the sperm. And then we do our crosses, and we actually do our crosses in cups just like this. This is your typical red Solo cup. So we put our eggs in here, we add a little bit of sperm, and then every once in a while we check under the microscope to look for fertilization. So once we see fertilization, which would be, we'd have a single cell, which would then become 2 cells, and then 4, we know that that whole process has worked, and we then put the entire culture into a tank of clean seawater for the larval growth period.
Okay, and is that behind us?
So these are some of our larval tanks here. These are 60-liter tanks. Typically we would stock these tanks with anywhere from 2 to 3 million eggs to start. So quite a few. A very ripe, mature female oyster could produce anywhere between 30 and 40 million eggs, but we only use a very small portion for the specific type of crosses that we do. The larvae will spend about 14 to 16 days in these tanks, during which every day we feed them. In a little while we'll talk about algae. Algae is extremely important to a hatchery, and we have full-time algae staff here that grow the specific types of food that we need for these larvae. They spend, as I said, about 14 to 16 days in here. We feed them every day, we assess their health, etc. And then when they're about ready to set, we remove the larvae from these tanks into our setting system.
Okay, and let's walk over here, Jessica. You showed me in these jars a number of the baby oysters. Can you show our viewers that now, please?
Sure. So right here, this is actually culch. So though this looks like a big jar of sand, this is ground up oyster shell. This is the material that we set our oysters on. So we put this in a downwelling system. The larvae swim around, and each larvae ideally attaches to a tiny piece of the sand-like material and then outgrows it, becoming a single oyster. Just for comparison, these are 1 to 2 week old oysters after they've been set on that culch, and there are just in this little bottle about 65,000 seed oysters. So just to give you an impression of how small they are.
Gosh. And this laboratory is primarily to do research to support industry, correct?
Yeah, that's very much so. So the department itself was started in 1997 as an initiative from the state to do something about the oyster problem. Historically, the harvest of oysters was obviously a very big deal in the Chesapeake Bay. By the 1950s, the wild populations of the bay had started to decline, and by the early 1990s, they were virtually wiped out. That was due to overfishing, habitat loss, and disease. And so this department started in the late 1990s. Has been all about rejuvenating that industry in the bay, and we do that through breeding. So we're constantly tasked with breeding a better oyster, so something that's disease resistant and grows fast. So we work a lot with industry, and we supply many hatcheries in the state of Virginia as well as outside of Virginia with their parent oysters that they then spawn similarly to what I just discussed to create the specific process that they need for their growers.
Okay, we're going to stop part 1 here and go to part 2. Ladies and gentlemen, stand by.